If you look up at the night sky tonight, some of the twinkling stars you see might not actually be stars at all.
Right. They could be something entirely different.
Yeah, they could be entirely inverted solar systems burning a fuel so volatile that, like, a single paper clip's worth could basically level a city. So today on our deep dive, we're hunting for antimatter.
We really are. And we have a phenomenal stack of sources to guide us through this today.
We do, yeah.
We're looking at advanced NASA presentations on space propulsion, some foundational physics textbook excerpts, historical research papers going all the way back to the 1920s, and even modern medical journals detailing radiopharmaceuticals.
It's a really eclectic mix.
It is, but by the end of this, you'll see exactly how theoretical math, rocket science, and, hospital brain scans are all intricately connected by the exact same subatomic phenomena.
Okay, let's unpack this.
Yeah.
Because the core idea running through all these sources is that there's essentially a mirror universe woven right into the fabric of our reality.
Yes, hiding in plain sight, really.
Exactly. But before we can talk about interstellar travel and brain scans, we have to understand the mechanics of what antimatter actually is. And our mission today is to do that without getting bogged down in dense jargon. We want to break this down so simply that a fifth grader could understand it.
I love that goal. It's crucial for a topic like this.
Right. So let's think of subatomic particles, like electrons and protons, as a highly specific lock and key mechanism. Imagine a standard Lego brick.
Okay, a Lego brick.
You know how much it weighs, and you know how its little plastic connectors snap into other pieces, right? Antimatter is basically a perfectly inverted Pizarro Lego brick.
That is a highly effective way to frame it, actually. Every particle of matter we interact with daily has a specific mass, a specific spin, and a specific electrical charge.
Right. So a regular electron and its antimatter counterpart, which is called a positron, they have the exact same mass, same spin, but their electromagnetic keying, their electrical charge, is exactly reversed.
Completely flipped.
Yeah. So while a normal electron has a negative charge, the positron has a positive charge. And while a normal proton is positive, an antiproton is negative.
The mass is identical, but the charge is flipped. But what's fascinating here is how we actually found this out in the first place.
Because we didn't just stumble over it.
No, we didn't discover it by looking through a telescope or digging it out of the ground. We discovered it because the math absolutely demanded it. It started on a chalkboard in 1928 with a British physicist named Paul Dirac.
Yeah, the sources spent a lot of time on Dirac's relativistic wave equation.
Right, so Dirac was trying to solve one of the biggest headaches in physics at the time. He wanted to write an equation that described how an electron behaves when it's moving at speeds close to the speed of light.
Which means combining two massive theories.
Exactly. He had to bridge Einstein's special relativity, which deals with high speeds, and quantum mechanics, which deals with the incredibly small. But when he finally built this mathematical bridge, he ran into, a fundamental algebra problem.
This is where the textbook excerpts use the analogy of a simple square root, right?
Yes.
Like the equation x squared equals 4. If you ask a fifth grader to solve for x, the obvious answer is 2, because 2 times 2 is 4.
But 2 is only half the answer.
Right, because -2 times -2 is also 4.
Exactly. The math inherently gives you 2 entirely valid answers, one positive, one negative. And Dirac's highly complex wave equation did the exact same thing for the energy state of an electron.
Oh, wow.
It perfectly described the positive energy electron we all know, but it also unequivocally demanded the existence of a negative energy electron. An electron with a reverse charge.
Wait, I have to push back on this a little bit.
Sure.
Are you saying Dirac was just trying to balance a complicated math equation, wound up with a weird negative number, and instead of just assuming, like, okay, sometimes math produces phantom numbers, he confidently predicted an entirely new fundamental piece of the universe?
He trusted the math. He really did. Nature actually builds these mirror particles, and Dirac realized his equation wasn't just a quirk, it was a blueprint.
That's wild.
He theorized that these completely inverted particles must physically exist out there somewhere, and the physical proof arrived just 4 years later, in 1932, thanks to an American physicist named Carl Anderson.
And Anderson wasn't just doing math, right? He actually built a trap to catch one.
He did. Anderson was studying cosmic rays, which are these high-energy particles constantly crashing into the Earth's atmosphere from deep space, and he used a device called a cloud chamber.
How does that work?
Well, think of a sealed glass box filled with a supersaturated vapor, almost like a really dense fog.
Okay, I'm picturing it.
When a charged particle zips through that fog, it ionizes the gas and leaves a little condensation trail. Very similar to a miniature airplane contrail, you can literally see the physical path the particle takes.
But just seeing a line in the fog doesn't tell you if it's matter or antimatter, does it? Like, how did he know he caught Dirac's mirror particle?
The magnetic field was the ultimate lie detector.
Ah.
Anderson placed a massive, incredibly strong electromagnet around the cloud chamber. Because particles have an electrical charge, passing through a magnetic field forces their trajectory to curve.
Okay, so they bend.
Right. Negative particles are pushed to curve in one direction, while positive particles are pushed to curve in the exact opposite direction.
Oh, I see where this is going.
When Anderson photographed the contrails in his chamber, he saw a particle that had the exact mass and behavior of an electron, but it was spiraling the completely wrong way in the magnetic field.
Because it had a positive charge instead of a negative one.
Exactly.
The physical path it took proved that Dirac's math wasn't just a theoretical phantom. Anderson actually caught an anti-electron on camera.
He named it the positron, and he won the Nobel Prize for it. So we proved that the mirror universe exists. But the next logical step is understanding the interaction between the two.
Which brings us to what happens when you force these two completely inverted puzzle pieces together. And based on the NASA propulsion documents, peaceful is definitely not the word for it.
Not at all.
In our daily lives, when we want to release energy, we rely on chemical reactions. Like if I burn a piece of wood, I'm just breaking chemical bonds and rearranging electrons. I get fire and heat, but also get smoke and ash. There's leftover mass.
Right. The wood hasn't ceased to exist. It just changed shape. Chemical reactions are essentially just localized reshuffling.
But when matter meets antimatter, there's no reshuffling. There's no ash.
None.
Don't think of matter and antimatter as two physical objects colliding and breaking apart into smaller pieces. Think of mass as frozen energy. Matter and antimatter are perfectly inverted. They're like two opposing sound waves.
That's a great way to visualize it.
When the peak of one sound wave perfectly overlaps with the trough of another, the structure of the wave completely cancels out. When an electron and a positron touch, their structures cancel out, and they unfreeze all their stored energy at once.
The physical particles completely cease to exist.
Exactly.
This phenomenon is known as annihilation. It is the purest demonstration of physics we've ever observed. Exactly 100% of their mass is converted back into the raw currency of the universe, photons and kinetic energy.
Pure energy.
Yes. This is Einstein's famous equation, E equals mc squared, playing out with absolute, terrifying perfection.
And to really understand the sheer scale of that perfection, we need to look at the numbers NASA is working with.
The numbers are staggering.
They really are. When we launch a rocket into space using standard chemical combustion like burning highly volatile liquid hydrogen and liquid oxygen, we generate roughly a few megajoules of energy per kilogram of fuel. Solid rocket boosters give you about 5 megajoules per kilogram.
Which is a respectable amount of localized pressure. It's enough to fight gravity and get us to orbit.
Now, if we step up to nuclear fission splitting heavy uranium atoms apart, like in a nuclear submarine, that energy density jumps to roughly 80 million megajoules per kilogram.
A massive jump.
Huge. And if we ever master nuclear fusion, like what happens inside the sun, we could hit 350 million megajoules.
Yes.
But antimatter.
Yes.
If you annihilate antimatter with matter, the energy release is 90 billion megajoules per kilogram.
90 billion. It's an almost unfathomable leap in energy density.
It's 10 billion times more powerful than the chemical rocket fuel NASA relies on today.
To anchor that abstract number to a physical reality, consider this. If you took just 1 single gram of antimatter, an amount of material roughly equal to the weight of a standard metal paperclip.
Just a paperclip.
Right. And you let it annihilate with 1 gram of normal matter, the resulting energy release would be an explosive force of about 43 kilotons of TNT.
Oh my God.
That is roughly equivalent to a modern atomic bomb, entirely contained within something you could balance on the tip of your finger.
That's terrifying.
It is. The energy radiates out violently as high-energy gamma rays and highly charged subatomic particles called pions and muons.
Which honestly brings up a glaring logical flaw in the origin of our universe.
How so?
Well, if the Big Bang created the universe from a state of pure, unimaginable energy, and as we just established, energy condenses into perfectly equal parts of matter and antimatter,
Yes.
then the Big Bang should have created equal amounts of regular Legos and inverted Legos.
It's one of the most profound, unresolved mysteries in all of physical cosmology. It's known as the problem of baryon asymmetry. The mathematical equations dictating the Big Bang unequivocally state that the universe should have been born with an exact 50-50 split of matter and antimatter.
But if it did, wouldn't all that matter and antimatter have just instantly overlapped, canceled out, and annihilated right back into pure energy?
Precisely. If the universe had followed its own rules of perfect symmetry, it would have completely annihilated itself in the first microscopic fraction of a second.
Leaving nothing.
Right. It would have left behind nothing but an expanding sea of pure, sterile light. No galaxies, no stars, no carbon atoms, and certainly no us, but obviously you and I are having this conversation.
We are here, yes.
The universe is heavily dominated by regular matter. So somehow, nature played favorites.
But how does nature play favorites if the fundamental math says everything must be perfectly balanced? Did the universe just leave a back door open?
Physicists look to a framework called the Sakharov conditions, named after the Russian physicist Andrei Sakharov. Specifically, they focus on a phenomenon known as CP violation, which stands for charge parity violation.
Okay, break that down for me.
To simplify a very dense quantum concept, physicists used to believe in parity symmetry, the idea that if you flip a particle's charge and mirror its spatial coordinates, the laws of physics should treat it exactly the same.
Makes sense.
But it turns out one of the fundamental forces of nature, the weak nuclear force, does not play by this rule.
So the laws of physics essentially broke their own rules in the extreme heat of the early universe.
Exactly. The weak nuclear force fumbled the perfect symmetry. It treated matter and antimatter just slightly differently. It created a minuscule imbalance. For every 1 billion particles of antimatter that were forged in the Big Bang, there were 1,000,000,001 particles of regular matter.
Wait, just one extra. That is an unimaginably small margin of error.
But it was enough. The great annihilation happened. All the antimatter in the early universe was completely destroyed, wiping out an equal amount of regular matter in the process, filling the cosmos with radiation.
Wow.
But that 1 in a billion extra particle of regular matter survived simply because there was no antimatter left to destroy it. That tiny lingering fraction of leftover regular matter is what eventually cooled and clumped together to form all the stars, all the planets, and you and me.
We're the leftovers.
We are the microscopic leftovers of a cosmic rule-breaking event.
That is incredibly humbling. But if the universe effectively outlawed antimatter billions of years ago by destroying it all, how are we still studying it today?
Yeah.
Is it totally extinct in nature?
It's rare, but it's certainly not extinct. It's being created continuously right now. It just doesn't survive very long because it immediately bumps into the overwhelming abundance of normal matter and annihilates.
Right.
Antimatter is produced naturally anywhere there is an extreme high-energy collision. We mentioned cosmic rays hitting our upper atmosphere, generating showers of positrons. But the sources highlight an even more localized phenomenon, thunderstorms.
Yeah, the physics papers on terrestrial gamma-ray flashes, or TGFs, are wild. A thunderstorm isn't just water and lightning. It's essentially a naturally occurring particle accelerator.
It really is. The immense electrical fields generated within intense thunderstorm clouds can accelerate free electrons upward at relativistic speeds approaching the speed of light.
That fast, just inside a cloud.
Yes. And when those hyper-accelerated electrons smash into the nucleus of air molecules, the kinetic energy is so extreme that it undergoes pair production. The energy literally freezes into matter, creating an electron and a positron.
That's amazing.
So severe weather is naturally brewing up antimatter right above our heads. Furthermore, antimatter is created in natural radioactive decay. Potassium-40, which is an isotope found in bananas.
Wait, bananas?
Yes, bananas. It undergoes a specific type of beta decay that will occasionally spit out a positron.
Okay, so if thunderstorms are naturally churning out the most powerful, energy-dense fuel in the universe, and bananas are occasionally emitting it, why aren't we just scooping it up to fuel NASA's rockets?
That brings us to the great bottleneck of antimatter research, artificial production, and containment.
Because based on the Fermilab data in our sources, the math behind our current production methods is completely brutal.
Brutal is the polite way to say it. Because we cannot simply harvest antimatter from thunderstorms, we have to manufacture it. To do that, We use massive, multi-billion-dollar particle accelerators like the Large Hadron Collider at CERN or the Tevatron at Fermilab.
Right.
We take a beam of normal protons, use massive electromagnets to accelerate them to near the speed of light, and physically smash them into a heavy metal target like iridium or copper.
So we're basically trying to manually recreate the extreme energy of a cosmic ray collision.
Exactly. The sheer kinetic energy of that crash is so high that a tiny fraction of it converts into new matter and antimatter particles. But it's a staggeringly inefficient factory.
How inefficient are we talking?
Well, most of the energy from the collision just splatters into a messy spray of useless subatomic debris. The sources indicate it takes roughly 100,000 high-energy protons smashing into the target just to produce one single antiproton.
Wow. And even then, we have to catch it before it touches the metal walls of the facility and annihilates. Right?
Precisely. We have to use complex, supercooled magnetic fields to capture the antiprotons that just happen to be traveling at the correct angle.
Yeah.
The electrical efficiency of the entire process is abysmal.
Yeah.
You're pouring megawatts of grid power into the accelerator magnets just to yield an efficiency of about 5 times 10 to the -3. Because of this monumental inefficiency, the total amount of artificial antimatter ever produced in human history is just a few nanograms.
A billionth of a gram.
Right. If we gathered it all together in one place, the annihilation energy wouldn't even be enough to boil a pot of tea.
Here's where it gets really interesting, though.
Yeah.
Let's look at the theoretical horizon. Let's assume some future engineering breakthrough solves the manufacturing problem, and we can mass produce this stuff.
Okay, let's assume that.
NASA has actively modeled what an antimatter rocket would look like. It's called MAPS, the Matter-Antimatter Propulsion System. And the reason NASA cares about this isn't just about having a bigger explosion. It's about fundamentally changing how rockets are designed.
This is where the physics truly shines for deep space exploration.
With a traditional chemical rocket like the Saturn V that took Apollo to the moon, you're relying on the expansion of hot gas pushing against a bell nozzle. It's essentially just localized pressure.
Right.
Because chemical fuel is so heavy and low energy, the rocket is basically a giant flying fuel tank with a tiny capsule on top.
Yeah.
That's the mass ratio, the weight of the fuel compared to the actual payload. But with an antimatter drive, the energy density flips the script entirely. A MAPS rocket could have a mass ratio of 5 to 1 or even lower.
Because you aren't carrying thousands of tons of heavy liquid oxygen. You're carrying a tiny magnetically suspended droplet of antimatter. But what is truly brilliant is how the MAPS rocket actually generates thrust.
How does it work?
Well, you don't just detonate a bomb behind the ship and ride the shockwave.
Right, because there's no expanding gas to push against the ship anyway.
Exactly. When the antiprotons and normal protons annihilate inside the engine chamber, they convert into energy, but that energy briefly takes the form of those highly energetic charged particles we mentioned earlier, pions and muons.
Oh, the subatomic shrapnel.
Yes. These particles are moving at a massive fraction of the speed of light, and because they have an electrical charge, they interact with magnetic fields.
So instead of a physical metal bell nozzle catching expanding gas, the antimatter ship uses a magnetic nozzle.
It generates a tremendously powerful electromagnetic funnel at the back of the ship. This invisible magnetic field catches the pions and muons and forcefully directs them out the exhaust.
That's genius.
Because the exhaust velocity of these particles is close to the speed of light, the rocket generates massive forward thrust from a microscopic amount of fuel. This drops travel times to the outer planets of our solar system from years down to weeks.
It really is the ultimate deep space engine. Now, obviously, we don't have the infrastructure to build antimatter starships quite yet, but what genuinely shocked me reading through the medical and engineering journals is that we don't just study antimatter in high-end physics labs.
No, we don't.
We actually use it every single day right here on Earth to build better materials and save human lives.
That is the beautiful, quiet irony of antimatter. The most destructive mechanism known to physics is a crucial, delicate tool in modern diagnostics.
Right, so let's look at the materials engineering side first. There's an industrial technique called positron annihilation spectroscopy, or PAS. Let's say you're an aerospace engineer, and you want to ensure the titanium alloy you're using for a jet engine turbine doesn't have microscopic weaknesses that could cause it to shatter under pressure.
You can't see those atomic level defects with a normal microscope.
Exactly. So think of it like this. Imagine throwing a bouncing rubber ball to a pitch-black room. If the ball bounces around for a long time before hitting something, you know the room is mostly empty.
Okay, I see where you're going.
If it hits something instantly, the room is crowded. You need a probe that can navigate the atomic lattice of the metal itself.
So scientists shoot a beam of positrons, the antimatter equivalent of electrons, directly into the metal alloy. Now remember the lock and key mechanism from earlier. A positron has a positive charge. The atomic nuclei of the titanium metal also have a positive charge.
And in physics, like, charges repel each other.
Right, so as the positrons drift through the dense molecular structure of the metal, they are continuously repelled by the positively charged titanium atoms. They are forced to seek out the path of least resistance.
Which would be the empty spaces.
Exactly. They navigate toward the empty spaces, the microscopic voids or potholes in the atomic structure.
Once a positron gets trapped inside one of these microscopic potholes, it bounces around for a fraction of a nanosecond until it inevitably bumps into a regular, negatively charged electron from the metal. And the moment they touch...
Annihilation occurs. The electron and the positron vanish into a flash of gamma radiation.
Right. And by measuring the exact time delay, like how long the positron managed to survive inside the metal, before the annihilation, flash scientists can calculate the exact size and concentration of the microscopic defects.
If the positron survives longer, the pothole is bigger.
Exactly. And this technique helps us engineer stronger airplane wings, more resilient semiconductors, safer materials all around.
It's incredible. And then the medical community took that exact same subatomic annihilation mechanism and applied it to the human body. This brings us to the PET scan, positron emission tomography.
This is where theoretical quantum physics directly intercepts human health. If an oncologist suspects a patient has a tumor, they need to see exactly where those fast-growing cancer cells are localized, right?
Yes.
And cancer cells are incredibly active and hungry. They consume glucose sugar at a much faster rate than healthy surrounding tissue.
So the doctors harness that hunger. They inject the patient with a highly specialized radiopharmaceutical. It's effectively a synthetic sugar molecule, but it has been chemically tagged with a radioactive isotope, like fluorine-18.
Right.
And as this isotope undergoes its natural radioactive beta decay inside the body, it actively emits positrons.
So the patient temporarily becomes a low-level antimatter generator.
Essentially, yes. The circulatory system carries the sugary tracer through the body, and it naturally concentrates heavily exactly where the hungry cancer cells are feeding.
And this is where the physics of the PET scanner performs its diagnostic magic. The positron is emitted from the tracer directly inside the tumor. But it doesn't get far, does it?
No, it travels less than a single millimeter through the tissue before it naturally bumps into a regular electron from one of the patient's own cells.
The electron and the positron touch. They completely cancel out, and their mass is perfectly converted into energy. But what's crucial here is how that energy behaves.
Yes, the geometry is everything.
Because of the strict laws of physics, specifically the conservation of momentum, the annihilation doesn't just create a random messy flash. It shoots out exactly 2 gamma rays, each possessing exactly 511 kilo-electron volts of energy.
Very specific.
Very. And to conserve momentum, those 2 gamma rays must shoot out in exactly opposite directions, 180 degrees apart.
This specific predictable geometry is the entire key to the PA scanner. The patient is lying inside a giant cylindrical ring of highly sensitive radiation detectors. Because those 2 gamma rays travel in opposite directions at the speed of light, they strike the detector ring on opposite sides at almost the exact same mathematical moment.
The technical specifications say the scanner's computer registers these hits within a 5-nanosecond window. That's unimaginably fast.
It is. When the computer detects 2 distinct gamma ray hits on opposite sides of the ring within that incredibly tiny fraction of a second, it knows for an absolute physical certainty that an antimatter annihilation just occurred somewhere along a perfectly straight line drawn between those 2 detector hits.
Wow. It literally draws a perfect line straight through the patient's body.
Exactly.
And as the tracer decays, millions of these subatomic annihilations happen over the span of a few minutes. The computer layers millions of these perfectly straight lines on top of each other. The point in 3D space where all of those lines intersect is exactly where the tracer is clustered.
Right.
It maps exactly where the sugar is being consumed, lighting up the exact location and shape of the tumor in high definition, so the surgical team knows exactly what they're dealing with, like a high-tech game of connect the dots.
It's an incredibly elegant, life-saving application of E = mc², We are harnessing the absolute mutual destruction of matter and antimatter to map the human body from the inside out completely non-invasively.
It really is. So let's step back and look at the whole picture here.
Let's do it.
We started with Paul Dirac trying to make special relativity and quantum mechanics play nicely on a chalkboard in 1928. That mathematical anomaly led to the discovery of the inverted puzzle pieces of our universe. We realized that overlapping those pieces triggers the complete unfreezing of mass into the most powerful energy release physically possible.
Right. And we explored how a slight rule-breaking glitch in the weak nuclear force during the Big Bang is the sole reason our universe isn't just a sterile, empty void of light.
And we learned that while humanity struggles to manufacture even a billionth of a gram to power our future starships, we are actively utilizing the mirror universe right now to hunt down microscopic fractures in titanium and map out cancer inside the human body.
If we connect this to the bigger picture, it serves as a profound reminder of the intricate machinery operating just beneath the surface of our reality. The very atoms that make up your body, the air you are breathing, the device you are using to listen to this, they only exist because of a cosmic asymmetry billions of years ago.
We're basically the survivors.
We are the improbable survivors of a universal war between matter and antimatter.
It really makes you look at the physical world differently. Which brings me to one final mind-bending thought to leave you with today, straight from the theoretical physics sources.
Oh, I know where you're going with this.
We established that antimatter has the exact same mass and spin as normal matter. It behaves the exact same way. That means gravity affects it the exact same way. It can clump together just like regular matter does.
Which logically means that complex macro-scale antimatter structures are theoretically possible in the universe.
Exactly. So consider an anti-star, a massive sun made entirely of antimatter, fusing antihydrogen into antihelium in its core. The energy it releases, the photons, the particles of light, would be completely identical to the light from our normal sun.
Because there's no such thing as an antiphoton.
Right. The light itself carries no charge. So what if some of those twinkling stars you look up at tonight are actually entire anti-solar systems with anti-planets orbiting them?
We'd have no way of knowing just by looking at them.
Exactly. They would look perfectly normal through our most powerful telescopes. We will never truly know for sure unless we send a physical probe across the galaxy to visit one and touch it.
And if we do ever send a probe to touch an anti-star, well, given the physics of annihilation we just discussed, we know exactly what would happen to that probe.
Total annihilation. A complete cancellation of structure, unfreezing back into the raw energy of the cosmos. Thanks for joining us on this deep dive into the mirror universe. We'll see you next time.